Right, so in this class we'll be looking at plane geometry, right? Plane geometry, and everything has to do with plane geometry. The calculations, right? Everything has to do with plane geometry. Let's look at it. In plane geometry, I say we'll be doing angles between straight lines. There are basically 6 types of angles I want you to know. Basically, no more. We have more. We have different types of angles. But basically, there are 6 types of angles we need to know to help us solve questions as regarding to plane geometries, right? Angles between lines. Now, look at them. Well, we have what we call the acute angles. What are acute angles? Acute angles are basically angles that are less than 90 degrees. So angles are normally running from the zero edge. From the zero edge, it's going to be turning a circle, right? And if it turns from 0 down to the whole frame, it's rotating at 360 degrees. Right? So we are calculating it per slot. So if the angles run from here down to here, let's say half of it, and let's just bring a line like this. If it runs like this, right? I believe there are 4 quadrants. If you run half of the quadrant, a quarter of the quadrant, it has gone through 90 degrees. So you take from here to here to have 90 degrees. If it runs another quadrant, it has run another 90 degrees. If it runs another quadrant, it has run another 90 degrees. If it runs another quadrant, it has run another 90 degrees. So if it starts from here and begins to run and run and run and run till it gets to here, it has covered the complete circle of 360 degrees. So you're calculating it per slot. If the angle, for instance, if the line is running from here, in between here and here, if it's less than what we have here, the angle is running between somewhere here and here, just less than this, we call it what? We call it an acute angle, right? So the angle is an acute angle if it is between 0 and what? 0 to, let's say, 0 to 89.99 degrees, right? It's not completely a 90 degree, right? We call that an acute angle. So that's how you say it's an angle that is less than. And you look at this symbol is called theta. Theta is a symbol we use to denote the angle. So theta is less than 90. When theta is less than 90, which is this, if it's less than 90, you know it's an acute angle. Same goes for the next, right? We have the right angle. The right angle is an angle that is exactly at 90 degrees. It runs from here down. So it's a right angle triangle, right? It's run just one quadrant. It's covered just one quadrant, known as what? Known as 90 degrees, right? And so number 3, which brings us to number 3, which is the obtuse angle. Obtuse angle normally runs from here, which is 0 plane. This is 0 degrees. 0 degrees, so it runs from 0 degree down. We said if it's at this point, it's known as the what? The acute angle. If it gets to this point, which is the right angle triangle, it's known as what? Right angle triangle, right? And if it gets to anywhere between here and here, anywhere from here down, it's known as the obtuse angle. If it is running anywhere between here down, let's just use this frame. Anywhere between here down, it's an obtuse angle. It is less than 180. It is not completely a 180. It's not completely 180. It's just less than. Right? So it's just running from here. Let's put it this way. It's just running from here down, but it's not completely 180. So let's call this our B. If it's starting from A running down to B, if the line is running down to B, it is known as what? An obtuse angle. So that's what we said. So an obtuse angle is greater than 90. Of course it is. If you watch, if it runs, it's greater than 90 degrees, right? It's greater than 90 degrees, but it is less than what? 180 degrees. It's greater than 90, but it's less. See, it's not completely 180 degrees. This is our 180 degree plane. It's not complete, but it's just less than 180 degrees, right? And that brings us to number 4, which is what? The angle in a straight line. Number 4, angle in a straight line runs from here down. It runs from here and stops here at this straight line edge, right? So it's covering 2 quadrants, covering the first 90 degrees and another 90 degrees, right? So this is the angle on a straight line. Let's just put it this way. The angle on a straight line is the angle in a straight line plane. Right, so it's covering from 0 down to 180. So sum of all the angles in this angle on this plane is summing up to give us 180 degrees. Right, so that's what we call it angle in a straight line. Basically, that's what we call it angle in a straight line. Number 3, we have the reflex angle. Reflex angle, if you watch, the condition states that it is greater than 180 but less than 360. So a reflex angle is more than 90, more than this, right? Even more than this, it is running down, but it's not completely on the 360. It's just more than these two angles, greater than 180 degrees, right? So a reflex angle can run down from here. Right, this is 90, is greater than 90, greater than what? Than 180, also greater than whatever it is from here, but it is less than 3. It's not completely 360 degrees. So any angle that is covering from here to this part, right, it is a reflex angle. We call it a reflex angle, right? It's a reflex angle, not completely a 360 degree. That's why I have the reflex angle. And then the last angle, the basic last angle we have is what the angle at the point. That is, it is an angle that has it is an angle that has turned through a complete circle. See, it has gone through a complete circle, one complete circle, one complete oscillation, right? It has covered. It's known as angle at the point. And the angles inside this angle at the point, the angles in this will sum to give us 360 degrees. Reason being that we have this quadrant as 90, this quadrant as 90, sum them up, we have 180, this quadrant as well as 90, 270, and this quadrant as 90. So we sum all the angles that takes to turn through a complete circle is known as 360 degrees. I hope you understand what we just did. Haven't known what these are. These are not something we should be we should argue about. They are constant and standard numbers, right? So I just want us to know them, look at what they are, and then see how we can get to questions. See you in this video, guys. Thank you. Alright, so let's look at how to solve this question. It said, what's the value of angle theta? Right, it's not hard. Looking at this now, we have the angle on a straight line, right? Angles on a straight line, because we said angle on the straight line. If you check the previous video, we said covers the sum of angles. The straight line is equal to 180 degrees. Right, so in doing this, very simple. What do we do with this? We just simply add them up, right? Because we're adding all this angle, we're adding this angle, and we're adding this angle, and summing them, we have 180. So in doing that, it becomes theta plus 140. That is in summing both, taking the addition of both of them, will give us 180 degrees. That's the condition, right? Any condition, in as much as it's covering angle in a straight line, whenever we sum the angles inside this, we're going to get 180 degrees. Haven't done this, what do? We can't add these two now. They can't add, right? Or if we know that this is basically an alphabet, an unknown alphabet, and this is a number, right? An integer. So what do? We correct like things by moving this one out. The easiest way of doing it is knowing that this is plus 40, plus 140 degrees. We introduce the minus sign of it. If this is plus, we introduce a minus 140 and minus 140 here. Right, then we spread the equation on the left hand side. This is the left hand box. I've taught this when we're treating a simple equation, simple and linear equation. We spread this by saying theta plus what? 140, and then what? Minus 140 is equal to what? 180 minus 140. Right, look at this now. Plus 140 minus 140 is 0. So we'll take them off. Right, this will go. So we're left with this. So theta is basically equal to what? 180 minus 140. Therefore, theta is equal to what? This will give us what? 40 degrees. So in other words, it means that this now, theta here will give us just 40 degrees. And if we add both, you see that everything will sum up to give us 180 degrees. I believe you understand how this is done. It's just a simple overview. Easiest way of doing it, you might want to carry. I want to say, since we have theta plus 140 equal to 180, and move this one here. That's the layman explanation of what they do, right? But we don't carry in math. I'm just trying to show you an easier way. The plus, it crosses the equal sign, the plus changes to minus. The theta becomes 180. If it crosses, this plus becomes minus here, 140, because it has crossed this equal sign. So theta becomes what? 180 minus 140 becomes 40 degrees. As easy as it gets, right? Hope you understand what we just did, because we'll be doing more tougher questions as we get by. See you in the next video, guys. Thank you.